So hello everyone, welcome to tonight's program, Climate Change Panel Discussion, Reasons to Act and Smart Solutions. So tonight our expert panelists will discuss the causes of climate change, what happens if we don't address it, and bipartisan solutions being considered in Congress. The panel discussion will be broken into three parts, and the Q&A will be at the end, but feel free to use the chat. So without further ado, our panelists.
Okay, thank you, Duke. And I'm Andy Pinelli, and welcome to our presentation and panel discussion tonight, Climate Change, Reasons to Act and Smart Solutions. I'm Andy Pinelli. I lead the Chicago South Suburbs chapter of Citizens Climate Education. That's a nonpartisan volunteer organization, nonprofit that works to try to educate citizens about climate change solutions and advocates for climate action. I spent 30 years in the Fortune 500 in product development and innovation, and I'm interested in legislative solutions that promote innovation and effective ways to address the problem. So there's a lot of things moving very fast in Washington right now regarding climate change solutions that are being considered. So it's a great thing that you're here. It's important that you are up to speed on the effectiveness of those solutions. And when you leave this meeting, we'll even have some quick, simple actions that you can take to try to ensure that the smartest solutions are going to be the ones that are considered. So next slide. On tonight's agenda, what we'll be doing is talking about the science behind climate change and pragmatic reasons to act. And even if you're on the skeptical side of the science, I think there's going to be some things that you're going to appreciate. And we'll be talking about smart solutions that can help mitigate the problem in cost-effective ways. So next slide. So tonight with me, and I'm pleased to have Rick Knight, who has spent 41 years as a chemical engineer in energy and pollution control research with the Gas Technology Institute. Rick is a top science and policy research coordinator with Citizens Climate Lobby, and that's a nonpartisan, not-for-profit volunteer citizens lobby group. Also tonight, Rick, by the way, is going to get into some of the science and mechanics that's at work in climate change. Tonight also, we're pleased to have with us Mike Zanillo, a University of Chicago alum who was a senior director for global financial systems for McDonald's Corporation and also a chief information officer for a division of Motorola. Mike is the Illinois state coordinator of Citizens Climate Lobby, and Mike will take us through some of the smart solutions that we're seeing come out of Washington right now. So with that, I will turn it over to you, Rick. Thank you very much.
Okay, thank you, Andy. Let me move to my next slide. Yeah. All right, so this is part one, the climate change causes. And let's start with some definitions. Is this about global warming or is it about climate change? And what's the difference? Well, global warming is a change in the Earth's energy balance. Climate change is what happens when you alter that balance. So in fact, global warming causes the climate to change. Long before we showed up, changes in climate were driven by very slow natural cycles. Slow meaning tens of thousands of years. But now it's happening over a few decades. And to understand why, we have to understand the Earth's energy balance. So what's that? Well, here's how it works. All of the energy that comes, that warms the Earth comes from the sun, mostly in the form of visible light that passes right through the atmosphere. And about half of that sunlight is reflected back to space by the surface and by clouds. And the remaining sunlight that doesn't get reflected, it then warms the surface. And like all warm objects, that gives off infrared radiation. that depends entirely on its temperature. And some of that heat radiation makes it back through the atmosphere into space, taking heat away from the Earth. Now, this creates an equilibrium. Energy in equals energy out. And this is the energy balance. The temperature of the surface controls how much heat radiation goes back into space to balance that incoming sun's energy and settle down to an average worldwide temperature. But that's not the whole story. Some of the gases in the air capture outgoing infrared radiation according to their basic chemistry. Most of the atmosphere is nitrogen and oxygen. It doesn't absorb that infrared radiation, but there are some gases that do, like carbon dioxide, water vapor, methane, and some others. And these are called greenhouse gases. Because of this greenhouse effect, those few molecules, even though there are very few of them, they trap heat in the lower atmosphere where we live. And this raises the temperature until the surface emits enough additional radiation to restore that balance at a higher equilibrium temperature. Energy in, once again, equals energy out. And we're lucky it exists because it makes the Earth warm enough for life and civilization as we know it. But if somehow more of these gases are added, they absorb and re-emit more of those infrared photons coming off the Earth. And that raises the surface temperature some more, throwing that balance out of whack. The whole planet on average has to get warmer. Of course, weather fluctuates from place to place, day to day, from season to season, but over time those differences average out. And with greenhouse gases increasing, more heat is trapped every year on top of those natural variations. Now, nature also has ways to take back greenhouse gases. And these are called sinks. The main sinks for CO2 are plants, oceans, and rocks. First of all, green plants take CO2 out of the air to grow. Now, CO2 also dissolves in water, so the oceans draw some of it from the air. And third, minerals in the earth also take up CO2, but this takes thousands of years to happen naturally. And what about methane and water vapor? Well, methane is a potent greenhouse gas, but it breaks down to CO2 and water in a few decades, and water vapor only lasts a few days before it comes out as precipitation, either rain or snow, and also forming clouds. So these plants, oceans, and rocks act like a kind of a planetary air conditioner, keeping the atmosphere from warming too much and giving life the time to slowly adapt to those changes when they happen naturally. However, if those greenhouse gases are added too fast, the air conditioner can't keep up. Imagine it's a blistering hot day and someone opens all the windows and doors. You can set your air conditioner's thermostat as low as you like, but that air conditioner will never catch up. So that's kind of what's happening. That's what science tells us will happen. Let's see what actually has happened. This is the Keeling curve. Charles David Keeling was the geochemist who perfected a way to measure carbon dioxide in the atmosphere back in 1958. He worked diligently for more than 40 years to document the climbing CO2 level. The first warnings about its effect came back around 1964 because scientists already knew for a long time about CO2 and the greenhouse effect, and that it was building up from burning fossil fuels. But we've continued doing this, and here's the result. Just like the energy balance predicts, the planet gets hotter. This graph shows the total heat buildup we've measured for the planet, at least through 2014, and it's continued going up since then. So where do all these planet-warming greenhouse gases come from? That's not a mystery. They come from fossil fuels, from agriculture, and from land use change. Fossil fuels contain long-buried carbon that produces CO2 when burned. Agricultural emissions are mostly methane. Let me adjust my screen here a little bit. Okay, agricultural emissions are mostly methane from the cows and from their manure, and nitrous oxide comes from fertilizer. Now, while clearing of land for farming or development leads to a slight cooling due to reflection of more sunlight, if trees are removed by wholesale burning, it moves a lot of carbon back into the atmosphere as CO2, adding to the greenhouse gas total. But is all this enough to account for overheating a great big planet? Yes, it is. In fact, it's more than enough. But don't take my word for it. Let's see some numbers. I usually ask an audience, a live audience, who can tell me how long it takes the US to emit this amount of greenhouse gases? So since we're not live, people can't yell out an answer. Just think to yourself what you would like to guess. How much the United States, how long it takes the United States to emit this amount? It takes 1 second. That's right. In the time it takes me to say this sentence, America will have emitted over 1,100 tons of greenhouse gases. And 90% of this is from burning fossil fuels. And we know that for sure because we also see a buildup in the carbon isotopes, which are different in those fuels that have been buried for millions of years from CO2 that comes from natural sources that have not been buried. Okay, so global warming is real. It's due to greenhouse gases. They're still going up, and they come from us. Why is that such a big deal? It's a big deal partly because of what it's doing slowly but surely to the weather. Not simply that the weather is getting warmer, although it is, but more insidiously, it's getting more extreme. Well, what do I mean by extreme weather? Well, here are the things that mostly constitute weather: heat, drought, cold, precipitation, and wind. These things are connected in complex ways. For example, heat in the ocean can feed energy to a tropical storm, which then becomes a hurricane. And if it makes landfall, it can cause devastation through the wind and precipitation, but also secondary effects like flooding after a big storm. Or how about wildfires? Made more likely by heat and drought and exacerbated by wind. There are other ways these weather elements can be combined, but the question for today is, how is global warming caused by the buildup of greenhouse gases in the atmosphere connected to these events? Let's pick out one especially potent example of weather: hurricanes, bringing a combination of wind and precipitation that combine to do tremendous damage, including flooding. Let's first look at a fairly recent hurricane, Hurricane Harvey in 2017. It made landfall in South Texas and then just sat there and sat there and sat there, pouring a deluge of rain. Here's how one research team summarized it, along with a map showing how much rain fell that week. It was up to 60 inches of rain in some areas. And the estimated cost of Hurricane Harvey was $125 billion just to Texas, which was 17 times the entire FEMA budget for that year. And just a month later, we had Hurricane Maria. This Category 5 storm made a direct hit on Puerto Rico, killing an estimated 3,000 Americans and leaving the island still crippled after nearly 4 years. Like many recent hurricanes, it was not the wind speed that was most devastating, but the rainfall. This chart shows the maximum rainfall from storms that hit Puerto Rico since 1955. The vertical scale is rainfall in inches. You can't see it all here, but here's 40 inches up here. And here's Maria up here. A study published in 2019 concluded that this volume of precipitation is 385% more likely due to climate change. Once again, it's the volume of rain and the persistence of the storm that's so rough. So let's jump to a completely different kind of extreme weather: heat. Specifically, a brutally hot summer in southern and central Europe in 2017, the same year as Hurricane Harvey. Researchers at Climate Central ran 4 independent models to determine the change in probability of such a summer over time. They concluded their models showed that a summer like that one is now about 500 times, let me back up again, 500 times more likely to occur than it would have been in 1900. Now, one more example, wildfires, which are connected to heat and drought. Unlike the oceans, where higher temperatures and higher evaporation can lead to monstrous precipitation and feeding energy to these storms, persistent heat over land works differently. It steals moisture from vegetation, drying it out and setting the stage for fire. Now, fire is not weather, but of course, a secondary effect of weather. It makes it trickier to tease out the climate factor because there are many other potential factors, development and forest management and so on. But it can be done. And there was a study by the University of Idaho and Columbia University in 2016, just to make it clear how climate affects wildfires. The primary driver is drying out of vegetation. Lower snowfall in the mountains, earlier snowmelt, and high spring and summer temperatures drive evaporation, both from the soil and from the vegetation. Now, here's a chart from that study I mentioned. Climate change just about doubled the area burned in the western US over this 31-year period. That amounts to over 16,000 square miles. Just for context, that's more than a quarter of the size of the state of Illinois. Of course, these numbers don't capture the human and economic toll from these fires, but the point is that climate change is making them worse. So let me summarize what I've shown you. Rigorous attribution studies have measured how much climate change contributes to extreme weather. Contributes, I should say. There are other kinds of events I haven't yet talked about, but you get the idea. And the science is clear that climate change makes dangerous and costly weather phenomena more frequent and more severe. But how can we be so sure it's not caused by some natural cycles, like the Earth's orbit, or the sun, or volcanoes, or something else? Here's a chart of the measured global average temperature from 1880 to 2014. So, how about the Earth's orbit? Could some astronomical cycle be responsible? Well, no. That cycle actually had a very tiny cooling effect during this time. So what about the sun? Could it be the sun? You know, astronomers routinely measure the sun's output, and they can show us that it had zero effect on the Earth's temperature since 1880. Aha, what about volcanoes? Don't they spew out tremendous amounts of CO2? Sure they do, but it's about 100 times less than what we put out. And they also put particles into the atmosphere that have a short-term cooling effect, which you can see here in these little dips in the amount of temperature that they contribute. So I guess none of these natural forces warm the Earth. No, it really is the greenhouse gases. In fact, they account for more than enough to explain the warming. And if you go back and add up all the different curves and all the different human contributions, both natural and civilizational, the result matches the temperature quite nicely. Natural factors are insignificant, and the net impact of the human factors accounts perfectly for what's been observed. So now let me summarize the whole presentation. What all this means is that it's real, and it's caused by stuff that we're doing, not by some natural cycle. In other words, it's us. And I've showed you some reasons why it's serious. But fortunately, there are solutions, and you'll be hearing more about that from our next two speakers. So thanks for watching, but we'll As I said, hold the questions until after the last speaker. And now I'll turn it over to Andy. Andy, you're muted.
Can you hear me? Thank you. Appreciate that presentation, Rick. That was very good. And I just want to let folks in the audience know that we recognize there's about 40% of Americans that don't accept the idea that human activity is the main driver of climate change. And we understand not everybody agrees on that. I did want to mention that there is these 6, and there's a dozen behind it, that of our most prestigious scientific organizations. You've heard of NASA, NOAA, the National Academies of Sciences. They would all agree with Rick's presentation, and they put it on their websites. So if you're interested, explore what they have to say. And I think my point here is that even if you're still skeptical, what we need to understand is that there's so much information that points in this direction that we have to at least acknowledge the risk that the consensus science could be true. And when you start to view it at that point, you start to look for ways to take action as an insurance policy, if nothing else. So for those that are skeptical, we're really asking you tonight to put on your what if they're right hats. And then as we present solutions, you can start to look at them. And I think what you're going to find is that they are very much in line with conservative values. So enough said on that subject. I do want to continue forward with a presentation about kind of why we should act. And Rick alluded to this, but there's a very disturbing trend. If you look at this chart, this tracks number of billion-dollar storms from 1980 through to 2020. And on the left axis, it talks about the number of billion-dollar events, but on the right axis, it talks about the dollar volumes of the events. And what we see over that 40-year period is this disturbing trend of a 400% increase in both the number of billion-dollar storms and the total dollar volume of those storms, and that's inflation adjusted. So, and really when I say storms, I'm talking about storm-related or natural disaster events, because we're talking about wildfires, we're talking about increased intensity hurricanes, we're talking about rainfall events like the one in Houston, and flooding. So, there may be an opportunity to stop this trend from continuing. And where are we going? I think that's another big question for us. This is there's probably a dozen supercomputer climate models out there. This one is calibrated to a half a dozen of those. But they all say basically the same thing, that we're looking at a end of century increase, end of century increase to about 3.6 degrees centigrade. That's somewhere between 6 to 8 degrees Fahrenheit. The climate models range from 3 degrees centigrade to about 4.5. So if we look at that range, we can expect continued warming, and a lot of bad things happen when the warming occurs. But just 6 to 8 degrees may not seem like a lot, but that's an average temperature. The temperatures are cooler over water, hotter over land, and as an average temperature, it might be 4 degrees Fahrenheit in some areas, but 12 degrees hotter in other areas. And that's not conducive to a future of prosperity. Just to put it in perspective, we haven't seen sustained temperatures that warm for about 10 million years. And a lot of bad things happen as temperatures get warmer. As Rick mentioned, floods, wildfires, more intense storm, droughts, all these things tend to get worse when we're looking at warming temperatures. Now, this was said to be the #1 threat to the global economy. This was before the pandemic, but by a survey of actuarial societies. And just one state, and this speaks to the expense of it and the US expense potentially, is here's just one state. If it gets that warm, what we're seeing is a projection of about $390 billion, and that's just in flood-related activities from rising sea levels. And we have 16 coastal states that could be potentially at some risk here. So in 2018, the Trump administration put out the 4th National Climate Assessment. This talked about the US impact of climate change by mid-century and end of century. And I put this up as an example that, this is not just a coastal phenomenon that's going to suffer from this, but the Midwest is looking at crop yield losses that could be upwards to the range of 20-25%. By mid-century, this is corn and soybean yield loss due to wetter springs, hampering planting, and hotter, drier summers. And as our climate in the Midwest gets more humid as time goes on, there could be grain storage issues impacting that as well. But most concerning is that the US economy could shrink as much as 8 to 10%. This was a compendium of 18 different government agencies that worked on this climate assessment. And with some of our best scientific minds there. So that's another concern to take action. But for a lot of people, concerns range to threat multipliers for the military and the impact on military and national security. And with that said, Department of Defense, for most of the last decade, is called extreme weather events a threat multiplier. These events triggered by climate change. It leads to droughts, flooding, property destruction, and that can create food and water shortage issues that lead to refugee issues. And refugee issues can destabilize governments and draw US troops into conflicts. Now, there's a military readiness component to that. When we look at this Air Force base 2 years ago in Nebraska, which was underwater because of a early winter melt and heavier than usual spring rains, rendering it inoperable. The Department of Defense did a recent survey and came out with a report that said 74 of 79 operationally critical military installations could be threatened by climate change over the next 20 years. Now, there's opportunities here too. Currently, because of air pollution, we have 100,000 premature US deaths annually. This would be, and there's an economic cost to that. Now, if we make the conversion to clean energy or cleaner energy, we might be able to get that number down. And we have 40 million Americans that suffer with air that either have COPD or asthma or other respiratory issues. And also the particulate matter, especially from burning diesel, contributes to stroke and cardiopulmonary disease from particles that are 2.5 micron or less. So we're likely to see this number grow if we don't take action, but if we do, there's an opportunity to have cleaner water, cleaner air, and try to get that number down and the cost associated with that number down. So overall, and just wrapping up, why take action? Well, if we can come up with a way to act that is really the only downside risk might be a negligible economic impact. And by negligible, I mean it doesn't really impact our ability to grow the economy. It doesn't impact job growth. It doesn't add to the national debt, and it doesn't hurt consumers. If we can come up with an actions legislation that accomplishes that, and Mike's going to talk about this, then we really don't have much downside risk on this side of the equation. But we see that not acting has all these risks that we just talked about: military readiness, property damage, agricultural yield loss, increased health costs. So when the downside risk of not acting is catastrophic and the downside risk of acting is negligible, prudence dictates that we act. So some of us, myself included, we look to the market to provide innovation. And why isn't the market fixing this like it should? Well, the problem is that the market is broken. And why is it broken? Well, it's broken because the fossil fuel prices at the pump or the meter, they don't reflect their true cost of the products. And that's because of subsidies. It's a very heavily subsidized industry, tens of billions of dollars going to fossil fuel subsidies, which obscures the true cost of it. But also these health and environmental costs that we've talked about, they never hit the bottom line of fossil fuel companies, so they're not reflected in the cost. And because of a fluke of the market, carbon pollution is free. Anybody can contribute as much carbon pollution as they want, and it doesn't cost anything. So there's no incentive to invest in clean energy right now because the market is heavily tilted towards fossil fuels. So the solution is to put a price on fossil fuels that reflects more of their true cost, or putting a price on carbon emissions, which would accomplish that. So if we fix that fluke in the marketplace, we can expect innovation to help solve some of this climate problem. Think of the cell phone or the smartphone that's in your pocket right now, and how that's evolved over the last 30 years. That when you had to carry around a brick and a battery pack on a shoulder sling to make a cell phone call. When the markets are working, we can get that kind of innovation, and we need that kind of innovation to tackle this problem, but it won't start until we fix this market problem. So I'm going to turn it over to Mike now, who's going to talk about some of the effective and smart legislation that he's seeing coming out of Washington at this moment, and get into the weeds a little bit on some of those legislative possibilities. Mike?
Well, thank you, Andy. So as Andy said, this part of the presentation is going to focus on solutions. We've heard from both Rick and Andy talking about the causation of climate change, and Andy kind of focused on the impacts of it. For the remainder of our time together, we're going to talk about what can we do about it and what are some ways to solve it. So to just kind of recap a little bit of the science and the facts that Rick covered in his presentation, one of the ways of representing what he talked about how man has artificially added huge amounts of carbon beyond the natural cycle to the Earth's atmosphere. You can, and anything that's added, even though, as Rick said, there's a lot of complicated science, but in a general sense, that additional CO2 will likely be added to the atmosphere and stay there for hundreds of years, if not 1,000 years or more. So if you know how much we put into it, you know the warming effect of each additional ton of CO2, and you know the temperature range that we want to stay under, you can kind of put it all together and view it, if you will, as kind of a carbon budget. So that's what's represented in this bucket, if you will. And you can see how man has gone beyond the natural cycle of CO2 that would naturally exist in the air, and how we've added to that since the Industrial Revolution. And this particular chart shows where we've gone up through 2019. You then can see the little remaining budget we have left before we will reach the amount that will raise the temperature beyond what the scientists tell us is prudent, which is to aim for no more than 2.7 degrees Fahrenheit of warming. And that basically becomes our remaining budget. And then when you just do a lot of number crunching, you know how much we're putting in any given year, you know what you want to stay under. That's where you get to these guideposts that the experts tell us that we need to think about how to reduce our man-made emissions by 45% by 2030, and ultimately achieving carbon neutrality by 2050. So the key takeaways before we start talking for the remainder of our time about solutions is that this additional CO2 that we put into the air is largely irreversible. It, unlike so many other things that we may be familiar with, like when there was an ozone problem and we cut back on fluorocarbons in order to reduce that, which had, a very near immediate effect measured in years where we were able to close the ozone layer, the ozone hole. In this particular case, because of the length in which it stays in the atmosphere, every additional pound we put into the air is largely irreversible. That in order to get to some of these goals, even though you see numbers on here like 2030, 2050, that doesn't mean that those are the deadlines for when we need to act. We need to change our behaviors now to be able to get to that, because we're not going to be able to throw a switch in the year 2029 and reduce our emissions dramatically. So for the remainder of this presentation, I would imagine if you came to this call, you're probably in that category of people that maybe view climate change as a concern, and maybe you've done all the right things as an individual. Maybe you weather strip your windows, maybe you put more insulation in your home, maybe you buy renewable energy credits, you change light bulbs and everything else. But at the end of the day, the best estimates are that personal actions can only impact 10% of the problem. And the only way we're going to tackle the 90% of the problem is through public policy action of some sort. So if you now start thinking about how do we reduce and reach some of these goals that we want to get to, a 45% reduction by 2030 and net zero by 2050, this slide kind of is a broad brush of some of the levers we can push. One is by writing a boatload of regulations to try to capture all the different actions that need to be taken by individuals, by businesses, by different industrial processes, and try to write it all down in code, get it through regulations, get it past the lobbyists, eliminate the loopholes, and have it stand up in court, which to me is a little bit mind-numbing, thinking about how we would ever do it purely with regulations. And then that's where, as Andy talked about, a lot of the smart policies are really based on doing it in a much simpler way, making it more expensive, correcting that market failure that Andy referred to, begin to have the cost of fossil fuel products reflect the true cost of them, not just what the current fossil industry puts on their balance sheet, but what do we now know is the total cost of society that you've heard about from Rick and Andy. So that broad approach is called putting a price on carbon, and that falls into two camps: a cap and trade regimen or a carbon tax and fee. They're basically complementary in an opposite sort of way. So cap and trade basically has government specifying the amount of emissions that will be allowed in a given year, and then those industries that emit can buy the right to emit up to that cap, and then sometimes they can trade among each other if that there's variations in how dirty different industries are to kind of stay within the cap, and then that cap goes down every year. The alternative approach is not to necessarily specify what the cap is, but just make it more expensive, to begin to reflect the cost of that carbon in those products, knowing that it's just natural human behavior and it's natural good business sense for anyone or any business to try to avoid things that are costing more, because it's all in everyone's self-interest to do so. So that's basically the simplicity and the essence of a carbon fee or tax policy. It's certainly not rocket science. It's kind of normal human behavior. It is the price of anything goes up. There's motivation to begin to limit the consumption of that, both for your interest as an individual or in particular for a company that wants to maximize its bottom line. So, as Andy said, things are beginning to move more quickly than they have in a long time in Washington. There was a new Congress, we had an election, and there was a lot of carbon policies that were introduced in the last Congress. Already in the short time that the current 117th Congress has been in place, we've already seen the introduction of many climate policies. And the two that we're going to kind of focus on kind of builds on that carbon fee and dividend principle that Andy introduced a few slides ago. And we're going to talk in some detail with the Energy Innovation and Carbon Dividend Act, which is House of Representative Bill 2307, which got introduced in the last week or two. And then since we're all in Illinois, for those of you who follow him, Senator Durbin has likewise reintroduced into the current Congress a bill that he introduced late last year called the American Clean Future Fund Act, which is also a variation of a carbon fee and dividend policy. So this Energy Innovation Carbon Dividend Act, HR 2307, basically works on a very simple model that I think it's easy to get your head around. Those few points in which oil, coal, or gas are taken out of the ground, it's a very finite number of sources. Those folks that do that already count it meticulously because they want to be paid for it. There's already existing other tax structures that put normal taxes on it. So we would intercept and overlay that and add an additional fee that represents the tons of emissions based on the carbon content of that product, starting at $15 per ton in the first year, and then going up by $10 per ton, in some years by $15 per ton, based on whether the goals for the reductions are being met or not. And then for all that money that is collected, use none of it for the funding of government. Therefore, we would not call it a tax, because that's what, by definition, a tax is. We would then return 100% of the collected monies as a dividend to households, hence the name, carbon fee and dividend. And then because this is going to be reflected in the price of products based on the carbon content, and given so much of the American economy is based on either exporting or importing, we would implement a carbon border adjustment, which basically levels the playing field and unwinds it. So you don't penalize those American companies that have paid the fee and make them less competitive. They would get a rebate, but likewise, we would capture any kind of importer that is bringing their products in that don't have the benefit of that fee baked into their prices. They would then pay a fee upon importation. So that basically carbon border adjustment basically maintains a level playing field between exporters and importers. So we don't give an undue advantage to anyone, nor do we penalize any companies. So at the end of the day, we'll spend the next few slides talking about what we would expect to be the impact of such a policy. And we'll go through that in a handful of slides here. So because unlike the regulatory approach, which as I kind of gave a little bit of an inkling in, that they're difficult to write so many regulations, and it's human nature for lobbyists to try to exploit it with loopholes, and then whatever comes out of that process inevitably, in this day and age more so than ever, tends to get tied up in courts for years on end. Taking a policy that's based on a taxing fee principle, avoids the lion's share of that, because the right of government impose fees and dividends, impose fees and taxes is very well established. So therefore, any kind of a policy that's based on that probably isn't subject to lengthy litigation. And because it captures it at the original point of extraction, there's not a lot of opportunity to exploit it with loopholes. We know we're going to basically tag those products as they go through a supply chain because we've nipped it in the bud at the source that they came out of the ground. So by putting this kind of a fee structure in, by making those kind of fossil fuels more expensive to start with and then going up incrementally, but in a very gradual way, you send a very strong pricing signal to consumers, but more importantly to business people that are responsible for energy and transportation sectors, because they will see the handwriting on the wall and everybody will be incentivized to migrate at a significant faster pace than we already are to things that are carbon free, renewable energy, wind, solar, change transportation systems that are more electrified and what have you. So because of all that, we would expect a very quick reaction by the market, by private enterprise, resulting in a 30% reduction in 5 years. And because of that continuing price escalation, getting to where we want to by 2050. All of this would result in a lot of the things we're already beginning to see more and more of, renewables, wind turbines, offshore wind, solar panels will become more and more competitive because they will no longer be competing against their alternatives that are unfairly being priced lower than they should because they don't reflect the cost of climate change. This then will put into motion the business response and the private market response to move us at a very good pace to affordable clean energy. Andy kind of talked about, and obviously the focus here is on climate change, but as Andy said, it doesn't get a lot of news coverage, but even the continuation of burning coal, even natural gas, does a lot of degradation to the air that's really behind a lot of the health impacts that he referred to with COPD and asthma, both of which are on the rise in the population, that here you would actually see a savings of 4.5 million lives over the 50 years because of improving air quality, because renewables inherently don't pollute the air. Because it's not revenue generating for the government, the money stays in consumer hands. It gets cycled back through that monthly dividend, and therefore none of this burdens those folks that are living paycheck to paycheck by asking them to help to fund this transition to a cleaner energy portfolio. This monthly dividend offsets that for 68% of the lowest income households, so that they are either made whole and are being compensated for what they may be paying for by way of higher energy and transportation costs, or maybe in some cases slightly come out ahead. Because the renewable industry in and of itself is more job intensive than how lean and mean the fossil fuel industry has become, for every megawatt produced by renewable energy, you tend to create 3 times as many jobs as the current infrastructure based on fossil fuels. So that's why such a policy is actually very job friendly, with good jobs that are stable jobs, that are good paying jobs. And because of this being done without disruption or any kind of manipulation of private markets, it actually keeps businesses healthy. And we're going to talk more about that in the next few slides, with just the sea change we've seen in business support for taking action on climate policy, basically in the last year. So all this, I would kind of summarize that this is all the underpinning of the economic benefit that Andy referred to, that by committing ourselves to the creation of these new industries, by spurring the innovation that a more level playing field would have, by spurring the investment that would flow into renewable industries, we would continue to have a very strong economy by avoiding and mitigating the economic damaging effects of the climate change that Andy really did a great job articulating. So I talked about the business change that we've seen, and in the next few slides, I'll just kind of call it out. The Business Roundtable, which really represents the 200 largest companies of the U.S., and this is a quote from the current chairman of the Business Roundtable, who's also the CEO of Walmart, has come out calling for business action. Andy talked about the impact to what is a major portion of the American economy, the farming and agriculture industries. The Commodity Future Trading Commission is now, increasing their alert on the risk to the financial system that could be a result of more devastating crop losses and unpredictability in farm yields and whatever. And then most importantly, the U.S. Chamber of Commerce, which for years was, noteworthy in, I would say, not supporting climate action, almost at a 180 last August. And you can now see with their new policy that acknowledges that humans are contributing to the changes, and what they're calling for, as many organizations are calling for, policies that are practical, flexible, predictable, and durable. And that is what we would say constitutes carbon fee and dividend policy. Last, I'll call out another noteworthy organization that you wouldn't typically expect as being at the forefront of raising their voice on having a climate policy, but the American Petroleum Institute recently came out with support for climate action, and as I highlighted in the red box here, specifically supporting a carbon price policy. Excuse me. So this kind of a policy that they were talking about that basically puts a fee on the extraction of fossil fuels and then collects the money and returns it to households equally, would over time generate the numbers that you see here. It starts out small because we don't want to be disruptive to the economy, but yet we want to send a very strong pricing signal that builds year after year. And then as you can see with that dividend, as it gets returned to the families of four, we keep the money in the economy. Normally a tax would be repressive. This is not a tax because none of the money is being taken out of the economy. It's being immediately recycled in through the distribution of the monthly dividend. As I talked about earlier, and I'm going to go fast because I know we're running close, and we want to allow a few minutes for Q&A. A policy like this, unlike many other climate policies that actually place a burden on the transition on those folks that are least able to incur the burden and they're living paycheck to paycheck, by distributing this equally back to households, you actually get that effect that I talked about earlier, that 68% of households are made whole and they are not asked to share the burden. The distribution of the dividend basically offsets what they may be paying for in higher prices for energy and transportation. This is one of my favorite slides because we would certainly argue that a policy like this inherently, one can argue, is structured in a bipartisan way, and it's got this kind of a policy has gotten wonderful support from economists. 27 Nobel laureates, over 3,400 U.S. economists. But the point I would call out particularly is the 15 former chairmen of the President's Council of Economic Advisors, which are almost equally split between Republicans and Democrats. They've all come out in support of a carbon fee and dividend policy. Well, policy like this is only useful if it's effective. And if you remember that carbon budget that I talked about earlier, there are some targets that we need to be mindful of. And as you can see on this slide, unlike that top dotted line, which is the business as usual, and even the Clean Power Plan, which got a lot of attention in the day when Obama introduced it, really would have just taken a few snippets out of the emission reductions that are needed. And even the Paris Accord is really more of a first step. But a durable policy like this, which meets the goals of the U.S. Chamber of Commerce, really puts in place that longer term change in behaviors and actions that, as you can see in this chart, gets us to where we need to be by 2050. You don't have to take our word for it. Obviously, Citizens Climate Lobby, thought this was a good idea for a long time. Others now, like the Columbia University, turned their economists loose without any kind of direction, but in a very unbiased way, basically reaffirmed a lot of the analysis that I showed in the prior slide. In this analysis calling for a 36 to 38% reduction by 2030, and further validating the longer term emission reductions that you would realize. So as a final slide then, I would just say that, I would think that if you came to this presentation, you may very well share a concern about climate, and you may very well do a lot of those personal actions that I talked about earlier. But as I said, we really aren't going to get to the goals that we need to get and really avoid the effects that we all want to avoid without a concerted effort at the public policy level, because this is larger than individuals. It's even larger than any one country. And therefore, we would certainly encourage you to, look at this slide. If you agree with any of the things that you saw this year more than any other year, we would think is that golden opportunity to get something meaningful into law, because as we all know, things tend to grind to a halt in any kind of election year like next year will be. That this is really the year that we think our elected officials need to hear from people. That's the common theme that Rick, Andy, and I hear whenever we go to Washington. It's when the voice of the deniers really has fallen off in the last few years. But what you may hear in some cases from elected officials is, well, my constituents aren't really screaming at them and really aren't pounding at the door. And that's why we would really encourage you to leverage your networks, leverage your social media actions that you take, draw attention to this, because this is really the year that we really want to create that groundswell of support to give our elected officials that wiggle room that says this is the year we really need to get something over the goal line and begin to take a big bite out of the apple. So with that, I'll turn things over back to Andy to kind of maybe wrap things up for us, and then we'll use whatever remaining time we have for questions and answers.
Oh, thanks, Mike. That was great. And there are some things that you can do, and we alluded to this at the front end of the presentation. And when we're out talking to congressional representatives, they want to hear from their constituents. It's meaningful to them. And of course, you want to tell them to take action on climate change. But if we've moved the needle and you're thinking on a carbon tax or carbon fee and dividend approach, mention that too, because this is an excellent solution and a cost-effective solution that hasn't risen all the way to the top in thinking of either Republicans or Democrats at this particular moment. So if you're calling your congressional reps, and we urge you to do that once a month, because that's where it starts to make a difference. We've got some links here to where you can call or write your congressional rep, and they make it easy. Even if you don't know who your congressional rep is, they tell you who your congressional rep is and give you some speaking points or help you craft the letter. But whether you're whether you're a market-focused guy or you like the Energy Innovation Act or Durbin's bill, or even if you're a Green New Deal proponent, or whether you don't know what, but you want the market to solve it, when you're talking, when you're thinking of solutions, this is a solution that can fit with any other climate action proposal. It's inclusive. It buttresses those other initiatives. So our appeal would be to call your congressman and to tell them to take action on climate and give consideration to putting a fee on or putting a price on carbon emissions. So with that, we'd like to open it up, Duke, for any questions that are available from the crowd.
Yes.
See, I saw a few in the chat box.
So you can put in the chat, and I see how Rick has already responded to somebody. Feel free to put in the Q&A or chat. We will be reading both. And I've just recently put those links in the chat as well.
Okay.
Mike, we actually have two questions, or one question for Mike and one question for Rick. Mike, are you able to see it? It is.
Yeah, so the question I'll repeat it for everybody is how does the Energy Innovation Act and Durbin's bill fit in with Biden administration infrastructure bill or subsequent programs? And obviously, Biden just recently introduced his infrastructure bill. I would say the best way of characterizing Biden's approach, and it's good climate-friendly approach, I'll start by saying, is that he can control the levers that he can control from the executive branch. So within that ability, he has redirected a lot of effort for research and development, for various tax credits, for certain investments, and dictates to how the government spends money to be all done in a very climate-friendly way. But it doesn't. It's not as pervasive or as wide as broad brush as a carbon taxing bill would, because that goes everywhere, even beyond where the government is directly involved. To the point of changing the behavior of individual consumers and individual businesses, which is just across hundreds of different industries. So from that standpoint, I would say it's consistent. But as Andy said, these things can all exist together, but that Biden's infrastructure bill in and of itself isn't anywhere near as broad brushed and would not get to the overall climate goals that we're trying to get to. As far as Dick Durbin's bill, I would say that it's a very interesting bill, and it's and we could certainly point you to some sources. It is 70% similar to the Energy Innovation and Carbon Dividend Act. It is very similar in nature. It returns 70% of the money back to consumers. There's some changes in the allocations and some means testing and things like that. But then it does a direction of 30% of the money into basically a green investment bank, which begins to be a little bit like Biden's approach, where you now are having a government pot of money to fund research and development, or to give loan guarantees, or begin to play a more of an active hand in changing and jumpstarting some of that investment and innovation that's needed. So, I would say Durbin's bill, and this is maybe a gross generalization, is a little bit of a blend of the Energy Innovation Act and a little bit of what Biden's trying to do through his infrastructure approach.
Let me also answer out loud the question I got from the same gentleman. I think was it Al, about direct air capture. I'll read the question if I can find it. Yeah. No, I'm not finding it. Oh, okay. Is there any hope for technology that can suck CO2 out of the air and sequester it? Should R&D be invested in this kind of work? I think from a technical standpoint, from an engineering standpoint, these what you call direct air capture technologies are extremely unlikely to be competitive with simply policies that can reduce emissions as they're being emitted right now. I'm a little bit afraid that investing too much attention in that kind of technology could draw resources away from the more direct approach that Andy and Mike talk about, which is to price emissions so that fossil fuel companies will have to recognize the true cost of what they're emitting. And there's a lot more to be gained by reducing those emissions than trying to take the CO2 back out of the air. I'm all in favor of private entrepreneurs putting their own money into this research, but I would not advise putting government money into it.
We do have another question. So what are the limits on climate policy in the infrastructure bill for budget reconciliation?
I know this gets to that parliamentarian that is becoming probably nobody ever heard of, but now you hear about on a more frequent basis. I'm not an expert on his view. I know there's certain bounds to what is deemed can be put into a budget reconciliation bill. He recently made the decision that a minimum wage cannot be included in the last reconciliation bill that just went through. So which aspects of a climate policy would fit in that and which wouldn't? I don't think I'm necessarily the expert. It's a legitimate concern, and I know it's certainly getting a lot of attention, but I don't necessarily know what the answer is either, unless Rick, you or Andy do.
Yeah, from what I know about the infrastructure bill, it's kind of based on the assumption that we already know what needs to be done in order to advance on climate change and advance renewable energy. But there's a lot that the private market can do that the government just simply can't do. And as Mike had said before, the executive branch can only do so much. And also in terms of pushing a package to reconciliation, there is still only so much that can be done. You can develop a lot of infrastructure, and if it stays in the package, which is not a sure thing, it may help, but it's still not going to be enough to make those big cuts. As Mike pointed out about the carbon budget, and as Andy pointed out about how fast we need to get started, only carbon pricing can really drive the entire economy in that direction.
Yeah, that speed of effectiveness, and I was impressed with Mike's slide about 30% reduction of emissions in 5 years. The speed is so important because every year those net incremental carbon dioxide billions of tons, the gigatons, they go up every year, and it just keeps building that carbon debt that we have. So the faster that you can bring that down in this 2021 to 2040 timeframe is so important to bend that curve, because otherwise you really just don't have time to impact that end of century temperature range to the level that we need it. So fast action is critical, and that I think is really one of the biggest advantages to getting a price on carbon emissions that's steadily increasing. So it sends that signal to the market, and things start changing tomorrow. That's what I see as a big benefit to this.
What else do we have? Anything?
So if anyone has any other questions, once again, Q&A or chat, we'll give it a couple minutes here. But I do want to thank all of our panelists. The library thanks you for doing this for us.
It's our pleasure to be here, Duke, and we're grateful for the opportunity. We hope that the audience there learned some new things about climate change, why we should act, and what some of the solutions are that are out there. And don't forget, your congressional representatives need to hear from you. So call them or write them, or join us and go visit them.
Yeah, and get on Twitter, go on their Facebook page. They all have social media, and their staffers do look at those messages and kind of tabulate them, and they let their bosses know, here's what people are asking about this week. So it's important.
Well, in that case, I will close it down. Any last minute things?
No, great job, Duke. Thank you for your help on this, and thank you, Mike and Rick, for joining us on this presentation.
Thank you, Duke, for hosting us.
Yeah.
And we
Thank you.
sure
Appreciate
appreciate the audience for sticking with us. We know we threw a lot of information at you tonight, but don't forget, in the chat box, there's information on how to reach us. And also, did I put my contact information in there? I don't think I did. I'm going to quickly hang with this, Duke, for just a second while I
No problem. Yeah, we can give it a minute.
I put my information in the chat box for everybody.
Make sure you have that set to panelists and attendees.
Right. I've got it. Thank you very much.
All right. Yep, so all their information is in the chat currently, and I'll give it a minute before I close down. Thank you again.
Thanks,
Everyone have a great night, okay?
See you, everybody. Thank you. Okay, great job. Thank you.